The smell never left him. Gun oil, metal sawdust, the acrid bite of gunpowder residue hanging in the air like a permanent ghost. 1855, Ogden, Utah. The workshop was attached to the house, a simple structure of wood and stone, and for a boy named John Moses Browning, it was not a room, it was the entire world. He was 7 years old. His father, Jonathan Browning, was a pioneer gunsmith, not famous, not celebrated, just a man with calloused hands who understood metal the way poets understand words. In a frontier settlement where weapons meant survival, Jonathan Browning's rifles were currency. They were trust. They were the difference between a full belly and starvation. Young John watched. He did not play in the streets like other children. While boys his age threw rocks and chased dogs, John stood at the workshop bench, barely tall enough to see over its edge, watching his father's hands move with absolute precision. He observed how metal bent under heat, how springs compressed and released, how a simple mechanism could harness explosive force and channel it into controlled, devastating power. His father never shooed him away. Instead, Jonathan placed tools in the boy's small hands. "Feel the weight," he would say. "Metal speaks to you. You must learn to listen." John listened. He felt the resistance of metal as it resisted the file. He understood how grain and structure determined strength. He learned that weapons were not instruments of death. They were mechanical puzzles, and puzzles could be solved. By age 13, John had solved his first major puzzle. He built a complete rifle using only scrap metal found scattered around the workshop floor. Discarded pieces, broken parts, refuse. But in John's hands, they became something whole, something functional, something that shot with accuracy that rivaled commercial rifles, costing 10 times what this scrap metal assembly had cost to produce. His father examined it without speaking. Jonathan turned the rifle over, checked the action, fired it. The recoil was clean. The mechanism operated smoothly. Then he looked at his son, and for the first time he saw not a boy, but an engineer. Not a child playing with his father's tools, but a mind that could visualize complexity in 3 dimensions and transform imagination into metal. "You have a gift," Jonathan said simply. But gifts require stewards, guides, fathers. In 1873, when John was 19, Jonathan Browning died suddenly. The workshop fell silent for the first time in the boy's life. The tool sounds stopped. The grinding of the file against metal ceased. The smell of gun oil became a memorial. John inherited not just a workshop, but an entire philosophy encoded in steel and precision. He and his brothers took over the business. But it became immediately apparent that John was different from the others. While his brothers copied existing designs, making the same rifles their father had made, the same shotguns, the same proven models, John began to completely reimagine how guns worked. He did not inherit a business, he inherited an obsession. Over the next years, patents flowed from his mind like water. A single-action rifle that was simpler than anything on the market, a pump-action shotgun that revolutionized hunting, a semi-automatic pistol that European manufacturers studied with envious intensity. Each design bore the fingerprints of his father's teaching: simplicity, precision, a refusal to accept good enough. But there was one puzzle that consumed him: an automatic weapon. A gun that could fire continuously as long as the trigger was held down, not for glory, not for profit, for the sheer technical challenge. How do you harness the energy of a shot to eject the empty cartridge, load a new one, and fire again? How do you control recoil? How do you prevent overheating? How do you stop the weapon from destroying itself? The military laughed at him. Impractical, they said. No real application. We have the Maxim gun. We need nothing else. But John was not interested in what the military needed. He was interested in what was possible. He was interested in solving the puzzle his father had taught him to see in every piece of metal, every spring, every mechanical challenge. He did not yet know that his obsession would change the course of human warfare. He did not yet know about the grass. The 1880s. Ogden, Utah, was not a place where genius flourished. It was a place where men worked with their hands, where profit mattered more than innovation, where copying a successful design was considered wisdom, and experimentation was considered madness. But John Browning was not interested in wisdom. By the time he took full control of the Browning workshop in his early 20s, he had already begun to see what others could not. While gunsmiths across America studied the Winchester designs and the Colt patents, reverse engineering them to build cheaper imitations, John was asking different questions. Not, how do I copy this, but how could this be better? His first major innovation came in 1879, a single-action rifle that simplified the Winchester design. Fewer parts, better action, more reliable. Winchester Repeating Arms Company didn't just buy the design, they bought him. Or rather, they bought the right to manufacture his inventions. It was the beginning of a partnership that would span decades and produce dozens of firearms patents. Single-action rifles became pump-action shotguns. Pump-action shotguns became semi-automatic pistols. Each patent represented months of obsessive work, sketches, calculations, prototypes, failures, adjustments, more failures. But there was one design that consumed him, one obsession that money couldn't buy and rejection couldn't kill. An automatic weapon. Not a machine gun like the Maxim, which was massive, water-cooled, and required a team of men to operate. Something different. Something that could fire continuously as long as the trigger was held. Something that obeyed a single principle, harnessing energy that was currently being wasted. Every other gunsmith dismissed the idea. Generals called it impractical. Even Winchester wasn't interested. We make hunting rifles and civilian weapons, they said. Military contracts are not our concern. John didn't care what they thought. By the late 1880s, the workshop in Ogden had become a laboratory of obsession. His brothers watched him spend months on a single prototype, watched him fire rifles hundreds of times, studying the behavior of gases, the recoil, the mechanics of loading and ejection. John, his brother would say, why do you waste time on this? Winchester already buys everything you invent. We have money. We have success. Why chase a ghost? But John saw it differently. This wasn't about money. This was about solving a problem that no one else had dared to tackle. The first prototype exploded on the test bench. Not a small explosion, a catastrophic failure that could have killed him. The pressures involved were enormous. Thousands of pounds per square inch, temperatures that melted lesser metals. The gas needed to push a piston hard enough to cycle the entire mechanism, but not so hard that it destroyed the weapon from the inside. John calculated, adjusted, rebuilt. The second prototype functioned for exactly 3 shots before jamming permanently. The third broke a spring after 20 rounds, but each failure taught him something. John didn't see destruction, he saw data. He measured the damage, he analyzed the fractures. He understood that the spring steel he was using couldn't handle the stress. He found a different alloy, stronger, more flexible. The fourth prototype worked for 50 shots, the fifth for 200. By 1890, he had a working model, a gas-operated machine gun that could fire continuously for minutes without jamming. The mechanism was elegant in its simplicity, a small hole in the barrel, gases diverted into a cylinder, a piston pushed by those gases. The piston ejected the empty cartridge, compressed the return spring, and was pushed back by the spring, loading a new round. Over and over, automatically. He tested it in secret, firing hundreds of rounds. The weapon heated up, the barrel glowed red, but it didn't break. It kept working. John knew he had created something revolutionary, but the army didn't see it that way. In 1891, he demonstrated the weapon to high-ranking military officers. The demonstration was spectacular. The machine gun roared. Empty cartridges flew through the air. The target at the far end of the range was completely destroyed in seconds. When the noise stopped, John waited for praise. Instead, he found skepticism. Interesting as a technical curiosity, one general said, but what practical application does it have? Another, machine guns are defensive equipment for fortresses, not field weapons. We see no need. A third, simply, we already have the Maxim gun. John tried to explain the advantages: simpler design, fewer parts, better reliability, more efficient gas operation. Every technical argument was met with polite disinterest. The truth was that the military of 1891 still thought in the language of the 1870s. Battles were decided by disciplined infantry firing in coordinated volleys. Machine guns were oddities, curiosities, not weapons that would change warfare. John returned to Ogden defeated, but not broken. He knew what he had created, and he knew that someday the world would need it. He just didn't know how soon that day would come. June 1890. A shooting range outside Ogden, Utah. The day was ordinary. The sun was ordinary. The sky was ordinary. Nothing about this moment announced itself as the hinge upon which history would turn. John Moses Browning was 35 years old. He had already patented dozens of designs. He had already proven himself a master of his craft. The Winchester Repeating Arms Company purchased his patents. Hunters around the world competed for his rifles. He was successful. He was respected. He had everything a gunsmith could want, but he had not solved the puzzle. The automatic weapon remained elusive. Generals had rejected his prototypes. Investors had declined to fund development. The world seemed content with the Maxim gun, that massive, complicated, water-cooled beast that required teams of men to operate and maintain. John had built something simpler, something more elegant, but it did not work perfectly. Not yet. He arrived at the range alone. It was a test day. He was firing one of his hunting rifles, the kind he had perfected over years of iteration. Each shot was an experiment. Each firing was an opportunity to observe, to measure, to understand the physics at work. He raised the rifle. He fired. The shot cracked across the range. The bullet travelled downrange. The shell casing ejected. And then something happened that every shooter had witnessed thousands of times. The exhaust gases escaped from the barrel after the bullet departed. They rushed out with invisible force, invisible power, seeking the open air. But John was standing close to the ground. The gases, rushing from the barrel, struck the grass in front of him, and the grass bent violently. The vegetation was pushed by an invisible hand, compressed, forced sideways by the sheer force of those expelled gases. Every other shooter at that range had seen this phenomenon 1,000 times. John was the only one who saw it. He stood frozen. His mind, trained by decades in the workshop, by years of understanding metal and force and mechanical advantage, did something that changed everything. He observed the grass moving with the eyes of an inventor. He did not see a curiosity. He saw a solution. Those gases have power, wasted power. What if I captured it? He fired again, and again he watched the grass move. The same invisible force, the same energy being expelled into the air with each shot. Energy that could be directed, energy that could be harnessed, energy that could be made to do work. He rushed back to his workshop. His brothers recognized immediately the look in his eyes. When John had that expression, that intensity, that internal fire, it meant he had envisioned something revolutionary. It meant months of obsessive work lay ahead. It meant sleep would become secondary to the consuming need to bring an idea from imagination into reality. For weeks he sketched. Calculations filled page after page. He was designing a system that would channel the gases from a shot into a cylinder. These gases would push a piston. This piston would eject the empty cartridge, load a new one from an ammunition belt, and prepare the gun for the next shot, automatically, continuously, without human intervention. It was brilliantly simple in theory, incredibly complex in execution. The pressures involved were enormous. The timing had to be perfect. Too early, and the gases would escape. Too late, and the pressure would destroy the mechanism. The temperature of the gases was another problem. Overheated metal expanded, changed its properties, failed. He built prototypes. The first exploded on the test bench. The second jammed after 3 shots. The third worked for 20 shots before breaking a spring. But each failure was data. Each failure taught him something. John did not see defeat. He saw information. He adjusted dimensions by fractions of a millimeter. He tested different metals. He modified spring angles and tensions. He was solving the puzzle one variable at a time. Months passed. The brothers questioned whether all this effort was worth it. After all, Winchester already bought his conventional designs. They were making money. Why risk everything on a crazy automatic weapon idea that no one was asking for? But John was not driven by profit. He was driven by the certainty that it was possible, by the vision of that grass bending, by the absolute knowledge that he had discovered a fundamental principle that no one else had grasped. Then it happened. One of his prototypes worked. Not for 20 shots, for 50, for 100. The weapon fired continuously without jamming. The mechanism operated like a Swiss watch, even under extreme stress. The gases flowed through the system. The piston moved. The cartridges cycled. The rifle fired again, and again, and again. He had done it. A gas-operated machine gun. The foundation for every automatic weapon that would follow. Born not from military demand, but from the observation of moving grass. Born from a single question. What if? That question, asked on an ordinary day in June 1890, would change the course of warfare forever. April 1917. America declared war on Germany. The decision sent shockwaves through the military establishment. The American Expeditionary Force would need to be mobilized, trained, and equipped, all within months. Millions of soldiers, millions of rifles, thousands of machine guns. The United States Army possessed fewer than 1,000 modern machine guns. Fewer than 1,000. In the trenches of France, entire regiments were being annihilated by German machine gun fire. At the Somme, the British had lost 60,000 men in a single day. most of them to machine guns. Now American soldiers would face the same death. Generals knew they needed automatic weapons. They needed them desperately. They needed them immediately. And then someone remembered. John Browning, the old Utah gunsmith, the man they had rejected 26 years earlier, the man whose impractical machine gun had been gathering dust in forgotten arsenals while wars raged in Europe. They sent for him. John was 62 years old, an age when most men considered retirement. But when the telegram arrived from Washington, he didn't hesitate. He packed his notes, his sketches, his designs, and he traveled to the capital to meet with generals who were no longer skeptical. They were desperate. This time there was no skepticism. This time there was only hunger. John presented not one machine gun, but two. The first was an improved version of his original gas-operated design, lighter, more portable, more efficient than anything the Maxim offered. The second was something even more revolutionary, a heavy machine gun based on an entirely different principle. Instead of using gases to operate the mechanism, it used the recoil of the shot itself. Each time the weapon fired, the barrel recoiled slightly. This movement, this wasted energy that every other designer had ignored, activated the reloading mechanism. The demonstrations were spectacular. Browning's heavy machine gun fired continuously for several minutes without a single jam. Officers watched with stunned expressions. This was not the Maxim. This was something fundamentally superior. Simpler construction, 40 major moving parts compared to the Maxim's 200, could be manufactured faster, more reliable in mud and sand and the filth of the trenches. But there was a problem: time. Building factories, training workers, creating specialized tools, establishing supply chains. All of this would normally take a year, maybe 18 months. American soldiers were dying now. Every week of delay meant hundreds of casualties. Every month of delay meant thousands. John Browning, at an age when retirement beckoned, embarked on the most intense project of his life. He worked 18-hour days, supervised production, troubleshot manufacturing problems, trained military gunsmiths, flew between factories, solving crises that other engineers said were impossible. When manufacturers complained that certain parts couldn't be made to precise tolerances, John redesigned the parts to be easier to manufacture while maintaining perfect function. When metallurgists reported that available steel couldn't withstand the stresses, John specified new alloys and worked with suppliers to produce them. When testers reported problems, John identified solutions immediately. American industry mobilized on an unprecedented scale. Automobile factories were converted to weapons production. Machine tool companies created specialized equipment. Women entered the workforce en masse, operating complex machinery with precision that rivaled the best gunsmiths. Within months, not years, months, American factories were producing hundreds of Browning machine guns per day. The weapons arrived in France in early 1918. American soldiers received them with reverence. These were not the temperamental Maxims they had heard about. These were weapons that felt intuitive. That could be disassembled and reassembled in minutes without special tools. That could be repaired in the field by ordinary soldiers. The baptism of fire came during the German spring offensive of 1918. German forces, aware that fresh American troops were arriving in massive numbers, launched a desperate attack. Thousands of soldiers advanced across no man's land in dense waves. Browning M1917 machine guns opened fire for the first time in real combat. The sound was different from German Maxims, deeper, more constant. A barrage of bullets that devastated anything in front of them. American soldiers watched in amazement. The guns fired continuously, no jamming, no failures. What truly set them apart was reliability under extreme conditions. The trenches were a machine's nightmare: mud, humidity, dust, fluctuating temperatures. German machine guns frequently jammed in these conditions, requiring constant cleaning and maintenance. The Brownings kept working. Field reports reached commanders. One machine gun fired 20,000 rounds in a single day of battle, with only a short pause to replace its overheated barrel. Another had been partially buried by an artillery shell, dug out, quickly cleaned, and returned to service within minutes. Weapons that had fallen into mud puddles were shaken out, had their mechanisms cleaned, and continued operating. German commanders received intelligence reports. American machine guns are different, more reliable, more deadly than expected. It wasn't just technical superiority, it was psychological. American soldiers carrying these weapons felt invincible. German soldiers facing them understood they were fighting something revolutionary. By September 1918, during the Meuse-Argonne offensive, Browning machine guns were present in force. They played a crucial role in breaking through German defensive lines. The war ended in November, but the validation was complete. The army that had laughed at him in 1891 was now worshipping him. And John Browning, the boy from the Utah workshop, the dreamer who had observed moving grass, had become the most important weapons designer in the world. November 1921, Herstal, Belgium. John Browning was working at his bench in the FN Herstal factory. He was 66 years old, an age when most men had retired years ago. But John had never learned how to stop working. He was designing a new pistol, still innovating, still solving mechanical puzzles, still asking, how could this be better? The chest pain came suddenly. He tried to keep working. After all, it was what he had done his entire life: work through discomfort, solve the problem, complete the design. But this was not discomfort that could be worked through. He collapsed at his workbench, surrounded by the tools and sketches and half-finished projects that had defined his existence. John Moses Browning died that day, November 26, 1921, at his workbench in Belgium. No fanfare, no state funeral, no eulogies from generals. Just a death notice in newspapers. John Browning, firearms inventor, dead at 66. The world barely paused. But his work did not die with him. In 1933, 12 years after his death, the United States military approved a new machine gun, the Browning M2 50 caliber. It was based on principles John had developed decades earlier, refined by other engineers, perfected by time and field experience, but fundamentally his design. The M2 would become the most successful heavy machine gun in history. When World War II erupted, Browning machine guns were everywhere. The M1917 equipped infantry positions. The M1919 light machine gun, a marvel of portable automatic fire, armed assault squads. The BAR, the Browning automatic rifle, gave individual soldiers firepower that had previously required entire teams. And the M2 50 caliber? It was mounted on tanks, on jeeps, on ships, on aircraft. The B-17 Flying Fortress carried 13 M2s. When German fighters attacked, the sky filled with tracers. American gunners relied entirely on Browning weapons for survival. In the North African desert, where sand destroyed lesser machines, the Brownings kept working. In the jungles of the Pacific, where humidity corroded metal and heat warped precision parts, the Brownings kept working. In the frozen mountains of Korea in the 1950s, where temperatures dropped below freezing and ammunition became brittle, the Brownings kept working. In the steaming jungles of Vietnam in the 1960s and 1970s, where everything rusted and corroded, the Brownings kept working. Engineers from a dozen nations tried to develop replacements. Prototypes were tested, new contracts were awarded, modern designs were officially adopted. But soldiers in the field preferred the old, reliable Brownings. In the deserts of Iraq and the mountains of Afghanistan in the 2000s, more than 80 years after John Browning observed grass moving from exhaust gases, the M2 50 caliber was still in active combat, still being mounted on Humvees, still being fired by American soldiers at American enemies. No other firearm in history has achieved this record. 90 years of continuous military service in more than 100 countries, through 6 major wars, through countless smaller conflicts. The 50 caliber round, half an inch in diameter, over 2 inches long, capable of penetrating light armor and downing aircraft, had become synonymous with American military power, and it was his design. John Browning registered 128 patents during his lifetime. 128. Each one represented months of work, sketches, calculations, prototypes, failures, adjustments. The Colt M1911 pistol, adopted in 1911 and used by the US military for 70 years, his design. The Browning high-power pistol, completed after his death by his apprentice Dieudonné Saive, was adopted by more than 50 national armies, his design. Hunting rifles and shotguns bearing his name continue to be manufactured and sold today, more than a century later. His designs. But here is the deepest irony of John Browning's life. He was a fundamentally peaceful man, deeply religious, a Mormon who believed in using his talents for constructive purposes. He never gloried in violence, never celebrated the weapons his designs created. Yet millions of people were killed by weapons based on his designs. He never spoke publicly about this contradiction. Perhaps he never fully reconciled it. Perhaps he simply accepted it as the consequence of living in an era of global conflict. Today, his name is largely forgotten. Most people have never heard of John Moses Browning. They don't know about the boy in the Utah workshop. They don't know about the moment he observed grass moving in the exhaust gases. They don't know that he died at his workbench in Belgium, still inventing at 66 years old. But his fingerprints are on modern warfare itself. Every assault rifle descended from his gas-operated principle, the AK-47, the M16, the FAMAS, the HK-417, all of them use variations of the system he discovered by watching grass. The M2 50 caliber remains in active service in the armies of the world. American helicopters in Afghanistan, NATO forces in Eastern Europe, Israeli tanks, British armored vehicles, Japanese naval ships, all of them carry his legacy. John Browning observed something no one else had noticed. A simple thing, grass moving, wasted energy. He asked, what if? And that single question, that one moment of curiosity, changed the course of warfare forever. He never became famous, never received statues, never had cities named after him. But his work outlived empires. His designs remain in active military service more than a century after he died at his workbench. In the end, that is his monument, not carved in stone, but forged in steel. And still firing today.